Hi! In this video, we're going to take a look at a pretty simple application of what we've been covering in this section so far regarding arguments. So what we want to do is we want to time how long it takes a function to run. So if we call a function, we'll have a function name, and we've got the parameters, the arguments for the function. That could be positional and or keyword only arguments. So we want to be able to time this. So we want to write a function that can time it, and we want our function, our timing function, to be generic so it could work with any function and any parameters that are needed for that function. So let's take a look at how we might do something like that. First thing is I'm going to import the time module. We'll need that for timings later on, so we may as well get that out of the way. And let's go ahead and define a function called timeIt. And that function is going to then run and time the function we actually want to run. So what is it going to need? Well, it's going to need the function itself. And remember, functions are objects in Python, so we can pass them to other functions. We've seen that before. And we also need, though, arguments for that function, right? That function isn't just going to run by itself. Most likely, it might need arguments, positional arguments, and potentially even keyword-only arguments. So we're going to need to collect them. And that's pretty easy. We can collect them using *args and *quargs. So if we do that, let's just go ahead and print out args, and let's print out quargs. And let's just see what happens if I call timeIt with, let's say the function that I want to run is the print function. So I just have to specify the function name, right? I'm not making it callable. I'm not doing this, which would actually execute the function. That's not what we want. Here, I want the actual function itself. So just print. And then the arguments to the function, well, what happens when I call print? Well, I might want to print, let's say, 1, 2, and 3. And then what happens with the quargs? Well, maybe I want to change the separator, right, in the print to be space dash space, okay, something like that. And if I want, I can even add the end and change that to maybe a space and 3 stars, okay? So maybe that's how I want to run the print function. I want to run it passing this to it. So here you can see that we scooped up 1, 2, and 3 into args, and then sep and end ended up as keywords, parameters, arguments that ended up in a dictionary. So we're getting there. We kind of have what we want, but we're not actually executing the function, which is what we need to do. So let's go ahead and change that. Let's copy paste, or you can just modify what you've got up there. And I'm not going to print out args and quargs anymore. We know what it's going to contain. So what we want to do is we want to call the function fn, and we want to pass it the arguments and the keyword arguments, right? That's how we would pass it. But we've got to be a little careful here. This isn't going to quite work, right? If we do this and we execute this over here, let's see what we get. Well, we printed out this tuple 1, 2, 3, and we printed out this dictionary. What's going on? Well, remember that fn in this case is really just print. Well, what if I print a tuple? Is that really the arguments? No, it's a tuple. What if I print a dictionary? Are these actual arguments to the print function? No, this is just the second positional, right? It's the same thing as if I'd said print 1, 2, 3, right, as my first positional element. So the tuple, which I'm going to need to separate here using the parentheses to indicate this is the first element, and then the second element was a dictionary, which happens to be sep. What did we make it? A space, right? And then we had end as well, which was a space and 3 stars, I think. Okay. So yeah, sorry, I need to put the closing print. So this is what we actually did, right? When we executed this, we actually just executed this. So what do we need to do? Well, we want these args to become actual arguments. So we need to unpack them, right? We need to basically do this. You remember how we were unpacking lists and things like that when we were then able to, like when we did the merge of lists, for example, or dictionary merges, we did a ***, right? So we have to use a *** to unpack the dictionary. So now if we do this, now you'll see what we get. Now we get what we originally wanted. It executed the print function with 3 positional parameters, 1, 2, and 3, and then it specified sep and end as the separator and end for that. And so we have the separator and we have the end of the line. Okay, so much better. That's what we want to do, right? We want to be able to just run this function from within this, because now we can time it. But there's one additional tweak that I want to make. I want to be able to specify when we run the time it function, the number of times we want to do this. And so I'm going to need to specify a keyword only argument that's going to be called rep, and I'm going to default it to maybe 1. So by default, it will run 1 time. Now you think that this may affect quarks that we're going to send to fn, but it won't, because this is a named, right, keyword only argument that's going to be, populated right here. So it's not going to get, so if I have rep in here, right, if I put rep equal to 5, it is not going to go into quarks. It's going to go into rep. So quarks is still going to be just the sep and the end. All right, so that's kind of what we wanted. Let's make sure that this works. So now I'm going to say for I in range of repetition, and we're just going to repeat this function that many times. So now let's see what happens. We should get this printed out 5 times. The only thing is I'm going to put a carriage return. I'm going to put a new line at the end. Otherwise, it's all going to end up on the same line. I want to differentiate the lines. So let's go ahead and run this. And indeed, we get that this thing was repeated 5 times. Right? So it's pretty neat. We were able to essentially pass the parameters through from here to the inner function that we called here. So now let's go ahead and time things. So I'll leave that up there. I'll just copy paste. And let's put the timings. Well, for the timings, all we need to do is basically use start equals time.perf counter. Okay. And then over here, after the loop is finished, we'll say time.perf counter again. So we'll look at our perf counter value, and then we'll just return the elapsed time and minus start. But of course, we've done some repetition, so I want to divide this by rep. This will give us kind of the average runtime. Okay, so pretty good. So we've got it. So now if we were to do this, we could call, time it. Well, we could just basically rerun this. Right? And there we go. It tells us that it executed in that amount of time. So each function, on average, that's how long it took to execute. So let's go ahead and write some functions that actually take a little longer to run. And let's see. So what we're going to do, we're going to create a function that is going to calculate, that is going to create a list, essentially, or calculate powers of n for k, n to the power of k for k in some range. So how are we going to do this? Well, let's go ahead and call it compute powers, and I'm going to call it function number 1, because we're going to write 3 different versions of the same function. So what do we want to do? We're going to want to calculate powers of n, right? And then we want to have a start and an end. So we want to say we want to start at n to the power of something and do the calculations up to n to the power of something else, which is going to be the start and the end. And I want those to be keyword only arguments. So I'm going to put a start to stop the positionals at that point. Then I'm going to make a start. Start, I'm going to default it to 1. It's like, if you don't specify what the start is, it will just start at 1. So it will start at n to the power of 1. And then it will continue up to the end. I'm not going to specify a default for end. This will force the caller to actually specify the end value. So we're going to calculate n to the power of 1. And if n was 10, we'd go up to n to the power of 10. So let's go ahead now and just use that. So we're going to do a for loop, right? So we're going to start with something pretty straightforward. So we need to create an empty list, and we're going to populate the powers of n inside that list. So for I in range of, well, what do we want? Well, we want to start at start and end at end, right? So that's our range. And then we could say results dot append. We're going to append powers of n to the power of I. Okay? And then we're going to return the results. So there's our function, and we can call it, right? We can see what it does, and let me actually call it compute, not computer. And let's go ahead and compute powers version 1. Let's say we do powers of 2, and we'll let it start at 1 by default, but we'll end at maybe 5. And there we go. We have 2, 4, 8, 16, right? So remember, the end doesn't include end. Okay, we're going to do our range, so it's going to be up to but not including the end. So we're going to use the same kind of way of doing things here. Okay, so that works. That's fine. Now let's go ahead and do this again. We're going to call it def compute powers 2 n, and we'll use the exact same definition for the parameters. But in this case, we're going to use using a list comprehension. And again, if you don't know list comprehensions, we'll cover those in detail later on in this course. But for now, we can use a list comprehension, which is very simple to write. We're going to want to return n to the power of I for I in range start, comma, end. Right? So this will be our list comprehension. So now we can run it, just make sure it runs, and it does what it's supposed to do. And there we go, 2, 4, 8, 16. So that works as well. And then lastly, I'm going to copy paste this. We're going to do a third version, but in this case, we're going to use generators. So this is going to be using generators. Again, if you're not familiar with generators, don't worry, we'll cover those in a lot more detail later on in this course. And I'm going to copy this, and this is using a generator expression to be more exact. So let's go ahead and put that in. And all I need to do here is to use round brackets instead of using square brackets, which would be a list comprehension. So let's go ahead and do that. And let's go ahead and run this. Now you'll see that there's a slight difference when I run this, right? I don't actually get my list. I get this generator object. It's a little different. And so to fix that, I'm actually going to create a list out of it essentially, and then show the list. And so there we go, 2, 4, 8, 16. We'll get into generators in much more detail, but I'm not going to spoil the surprise quite yet. The last thing we now need to do is to actually time those functions. And so we're going to use our timeIt function that we wrote. Now what does timeIt require? Well, it requires the function that we want to run. Well, in this case, it's going to be compute powers 1. And what do we want to compute? Well, we need to pass it n, right? N, and it's the same for compute 1, 2, and 3. So we can use this, look at this one. So we need n, which is a positional, which is, we're going to do powers of 2. We have then start and end. Now we don't have to specify start because it defaults to 1, and that's where I want to start. But maybe you want to start somewhere else. So maybe start at 0 or start at 1 if you really want to make sure that it's 1, even though it's the default. We'll start it at 0, and then we'll want to end, and we're going to run this so it takes actually a certain amount of time. We're going to calculate up to powers of 20,000. And then lastly, we need to put the repetition. Rep equals, and how many times do we want to repeat running this function so we can time it and get an average of the timings. So let's say we want to run this 5 times. Now, the order in which you specify the keyword arguments doesn't matter. We could actually put it here, right, in the middle. It doesn't matter. The order doesn't matter. Okay, so let's go ahead and run this and see what we get. And it will take a few seconds to run. There we go. So on average, it takes about 0.49 seconds to run this loop over here with n equal to 2 and start was 0 and end was 20,000. So now we can do the same thing, and basically we can just copy paste this, and we're going to time it using 2. Now I also want to show you that even though this here is a positional argument, technically we can pass it as a named argument. Let's see what happens when we do that. Works just fine. What happened? Well, remember that even though we've specified it here as a named argument, as a keyword argument, what's going on in here in the timeIt, right? It's going to put it into kwargs, right? If we were to print out this when we pass a named variable, let's say we say here, well, we have the named variables here, right? So it's the same thing as saying, let's say n equals 1, right? Let's just actually test this out. N equals 1. And then what do we have? We have start, rep, and end. Okay, so let's go ahead and, if I can find it, let's say we have start equals 0, end equals 20,000, and rep equals 5. Okay, and I probably, yeah, I can't run this. So let me redefine. Let's just redefine this very quickly, and then we'll fix it back up. Let's just go ahead and print, right? Args, rep, and kw args. I just want to show you what's actually happening. So now you can see that the args has nothing in it, right? Then our rep was 5, so there we go. Here's the rep of 5, and then quarks contains the n, right? But now when we call our function over here, it's expecting an n. So it's getting its positional through a named argument. And that's perfectly fine as well. So it's just kind of bouncing around, and that's fine. So that's why it works. So let's go ahead and just redefine this, make sure it's going to do what we want. So basically, yes, I can specify n equal to 2 this way, right? And here we get approximately the same time that it took, 0.49. And so lastly, let's go ahead and run this with the third function that we had. And that runs a whole lot faster, 1.9 times 10 to the negative 6 seconds, right? As opposed to half a second. So this is very, very fast. But before you go and start thinking, oh, I'm going to use generators for everything, I'm kind of, tricking you a little bit. And we'll see when we get to generators later on in this course. But a generator doesn't actually generate, the list. It generates a generator. A generator expression, like we have here, creates a generator. And generators don't actually compute their contents. They compute them one at a time as they are being requested. Which is why, when we did this, and actually let me just show you outside of that, let's go ahead and write a generator expression here. So we'll say a equals, let's say 2 to the power of I for I in range 5. Okay, so we'll go from 0 to 4 and we'll take a look at what we get. So now if we print A, well, we don't get a list, we get this generator object. And this generator object didn't actually calculate everything. If we want to get the list, if we want to get the generator to calculate everything and give it back to us in a list, we can do so by just using the list constructor and passing it the generator. Again, we'll cover this in a lot of detail later on in this course. But now if we do this, well, of course, if I do 2 to the power of 1, we'll just get 2's, right? And that's so it worked correctly. Let's do that again, right? And now we'll get powers of 2 to the 0, 1, 2, 3, and 4 as the powers of 2. So that's why this looks like it runs very fast. It's because it didn't actually do this calculation here, right? It just returned the generator. It created this generator, but it didn't actually evaluate anything. Now, if we were to here, instead of returning the generator, if we were to then do the list of the generator, right? Now, in this case, I wouldn't need to say list anymore because it is returning a list. So I get the 2, 4, 8, 16. And now if we were to time this, let me go ahead and copy paste over here, then you'll see that now it actually starts using more time, so 0.48. So again, it's in line with the other methods. But the advantage with generators is that if you don't use up all the values, then it doesn't spend the time calculating them, and you're not necessarily spending the time up front calculating everything. So, maybe it makes your code maybe a little more responsive, your program a little more responsive, whatever the case may be. There are use cases for generators, and we'll get to that when we get to that section. All right, so that's it for an example of how we can use args, star args and keyword only arguments and the star quarks to pass things around. So it's a pretty neat way. Python is very, very flexible when it comes to that. All right, thanks for watching, and I'll see you in the next video.